Our next speaker this morning is David Archibald. You can come forward, please, David. Ladies and gentlemen, David Archibald.
Thank you, Peter. It all starts with the oil price. The International Energy Agency was set up by the United States to talk down the oil price, to say that we have an abundance of oil. But they changed their tune about 2 years ago, and Fatah Birol, the chief economist, said that one day we will run out of oil, and we have to leave oil before oil leaves us. The only country to do that basically is China. We'll get to that later in this presentation. This is a graph of the oil production from 1965 with a projection to about 2030. And we are at the moment just on the cusp of a major decline in the amount of oil produced in the world. You'll see here the United States peaked out in 1973, as predicted by Tim Hubbard back in the mid-50s. Going on to the oil price itself, this is the oil price in constant dollar terms from 1861 up to 2011. What I want to bring your attention to is this period of inherent oversupply that started with the discovery of the giant East Texas field in 1930. As a consequence of that, the Texas Railroad Commission was given the task of running the world oil supply to make sure the oil price didn't collapse. US production peaked out in 1973, and with the first and second oil shocks of 1973 and 1979, the role of stopping oversupply was taken by OPEC. And then in 2005, Chinese demand took off, and we're now in a period of inherent tightening supply. And this is what that might look like. Here's 2005, the breakover point, and the price has been running since. Now, at about $60 a barrel, it becomes worthwhile to convert coal to liquid fuels, as Sasol has been doing in South Africa for the last few decades, and China's taking up in a big way. And at $120 a barrel, it's worthwhile to close your existing coal-fired power stations and convert them to, and use that coal for coal to diesel, and replace that power generation with nuclear power. And that day is upon us. Now, a lot of people concentrate on just how much latent capacity is in Saudi Arabia, whether it's 1 million barrel a day or 3 million barrel a day or the like. But I don't believe that's the big story in the oil market. The big story is the decline in non-OPEC production. This is a projection done by 3 Kuwaiti engineers early last year. And you can see the web address that you can download this from. They've got a whole lot of other charts there also. But this is the big one. Non-OPEC production will halve by the end of this decade. And that will cause an enormous tightening of the market. It cannot be taken up or supplanted by any other source. Now let's look at a subset of that. This is the basically North Atlantic non-OPEC production. As you can see, there's the US peaking out in 1973. Norway and United Kingdom are now in decline, so is Mexico. The only ones increasing slightly is Canada at great expense in terms of capex per barrel. Now that gets on to the next stage, which is modelling the oil price response to this tightening demand. So you've got 3 variables, which is lower supply, increasing demand, and the price response of demand to that increasing price. Very difficult to model, but one thing we can do is just simply look at what happened to the oil price so far. And if you plot up the oil price logarithmically, you get a straight line relationship that's rising at 15.6% per annum. Now, we could assume that that 15.6% per annum will continue for some time. Just when is going to peak out is the question. And what that will mean to pricing, if that 15.6% per annum continues for the next few years, by 2014 we'll be up to $200 a barrel here. And based on some ABARE numbers of the cost of fertiliser and fuel inputs into Australian agriculture, this is what will happen in terms of operating costs. Now, there was also a recent US study by the USDA, by crop, on what the fuel and fertiliser costs are. In 2008, this study was, the data is based on. And working back through those numbers that you generate from those charts, I've come up with these estimates of what $200 a barrel would do to wheat and corn operating costs. They're basically up the same as the ABARE number, derived number of about 60% to 70%. But we've seen this before. This is an interesting chart, which is the wheat and corn prices in the US in constant dollar terms back to 1916. You see the Depression, you see the Second World War, you see the long slide in real prices as technology improved, and this spike in the middle, which is the 1973 oil shock. And a 75% increase in operating costs still won't take us below up to that peak. We're somewhere in that ballpark. But we've seen this in our lifetimes, basically. And this is what the increasing oil price means in terms of, this basically for a US audience, so I've put it in dollars per gallon. The US doesn't pay much tax. Oops. And for most states, they have a price just above the oil price if you throw in the retail margin and the wholesale margin. Australia, we effectively pay $190 a barrel at the pump, and in Germany they're currently paying about $340 a barrel at the pump. Now the optimal solution to this coming energy crisis, to my mind, is installing coal to liquids capacity to generate the liquid fuels we need. Nuclear replaces coal in power generation. And hopefully, at some stage, we'll have thorium reactors than the current uranium-based light water reactors, but that's a subject of a separate sort of presentation. I said before that China's the only country doing something serious about the leaving oil before oil leaves us. This is a projection of Chinese domestic production based on the study done by those Kuwaiti engineers. This is what their imports have looked like, historically projected. And what they're doing about it is installing a hell of a lot of coal to liquids capacity. They've got total planned production on announced and existing projects of 600,000 barrels a day. And to put that in perspective, Australia uses about 950,000 barrels a day. And more recently, they've announced that because of the success of those projects, that they're going to expand coal to liquids capacity dramatically. I've chucked this in to show you what else you might run your farms and the tractors and so on. This is energy density per litre by the different sort of fuels that might come along in the future. There's the optimal fuel, diesel. LPG is possibly a very good fuel, but you'll have to increase the size of your tanks by 50%. There's compressed natural gas, which will probably end up being a very good fuel for commuters here in places like Perth. And the energy density of lithium-ion batteries is extremely low. I don't expect them to get much market penetration. Now on to the food security aspects of the implication of the oil price rise and so on. Let's start off with Tunisia, where the Arab Spring started. The Tunisians are the world's champion wheat eaters. And basically the wheat consumption equates to about 2,500 calories a day. They have a lot of wheat imports. There are about 10 million Tunisians growing at 1% per annum. So that's another 10,000 Tunisians a year. Yemen. This is the Yemeni wheat consumption per capita from 1968 up to 2010. You can see the domestic wheat production doesn't change much. and had this big spike here in the wheat imports. And that's because they started exporting oil in 1987, and they could afford a lot more food. But as you can see, oil production has been declining, and with or without the Civil War, it's expected to decline very rapidly, since it will be almost all gone by the end of this decade. But they'll be left with a population that's still growing at about 2.5% per annum. On to Afghanistan, which to my mind is a pestilential nation of terrorists. The chief exports are tourism and heroin. What's happened there in their domestic wheat production? It's been flat. The Russians invaded here in the early 80s. There had been some imports up to that stage. Production and imports collapsed, but population growth didn't fall below 2%. The US invaded, population growth still up to now back to 2.7% per annum. Wheat imports have been rising dramatically. And this is what might happen to population in Afghanistan if someone else doesn't keep paying for the wheat imports that they use. There's the Russians, there's US involvement beginning, population's growing 2.7% per annum. If someone stops paying for those wheat imports, their population will collapse, possibly below their natural carrying capacity of about 12 million people. They're currently about 27 million people. If Afghanistan is to import wheat in the future, it's got to come through Pakistan. So what's happening in Pakistan? This is a graph of Pakistani wheat production from 1960 up to 2011, and it shows it went up fivefold in those 50 years, which is very impressive. If we look at it on a per capita basis, it's actually been quite static for the last couple of decades at about 120 to 140 kilos per annum. So wheat production has just kept up with their population growth. If they haven't got any more land or water to grow wheat, and the population growth continues about 2.5% per annum, then by 2030 we'll have an 8 million tonne per annum gap of wheat supply needed in Pakistan on top of what might be required in Afghanistan next door. And as you're aware, wheat yields now plateaued out since the mid-90s, so we may not be able to rely upon technology to deliver increased production. On to Egypt, and most of the crises in food supply will occur in the Middle East North Africa region in the next 10 to 20 years. Egypt currently imports half its food. There are 80 million Egyptians. There were about 4 million at the time of the Napoleonic Wars in 1812. At their population growth rate, they'll be importing 2/3 of their food by 2030. And they'll be less able to pay for it. As with Yemen, this is Egypt's oil production from 1965 to 2020. And they've had a long period of being able to export oil. They're now going negative on oil exports. They do export a lot of LPGs and natural gas as well, but their ability to pay for that food imports is dropping away very rapidly. Now, if Egypt goes on that trajectory to 2030, by 2030 they'll require to import all of the US wheat exports, current US wheat exports, which are shown here. This is domestic US production from 1960 and the net exports, which have been flat for the last 20 years on it. And in the big picture on US grain and soybean production, this is what it's been since 1960. As a previous speaker remarked, in the last few years, due to legislation, they now produce 100 million tonne a year of corn that goes straight into ethanol. And that could feed about 300 million people. Well, actually, this is the big picture view on US grain production. Wheat's been very flat, actually for 40 years on, but corn's certainly taken off as they feed their pigs and so on. On to South America, and the big story there is what Brazil's done. Their soybean exports have taken off dramatically in the last 15 years. And given that protein content of soybeans, that's equivalent to about 100 million tonne a year of wheat they're exporting in terms of protein content. And my previous speaker also mentioned Mexico. Mexico imports about half its food. Basically, you get the tonnage here in millions of tonnes per annum on the left axis, multiplied by 3, and you get the number of million people that can feed. Mexico's population growth is now about 1% per annum, so there's another million Mexicans per annum, and they would require about 300 to 400 kilos per grain each, which is about 40,000 tonne a year, but their import requirements are ratcheting up by. But once again, their ability to pay for that food is dropping away. This is Mexican oil production from 1965, with a projection to 2020. And by 2016, they'll be net importers of oil. Under Russia, which recently became spasmodically a large wheat exporter, due to that drought in 2010, their production dropped just about 20 million tonnes down to their domestic production level. Here in Australia, we believe we're a big exporter, but we're the most drought-afflicted place on the planet, such that we have very big spikes in what we can export. And if we want to believe in sustainability and food security for Australia, we really don't have that much of a buffer that we really think we have. On to what the total picture looks like for the world. World grain production is about 2.2 billion tonnes, and here I broke it down by major country and by major crop. But on to where the food might come from. This is a map produced about 8 years ago of soil quality around the world. And the good stuff is this dark green stuff with high resilience and high performance. And you can see that the good stuff, the dark green stuff, is largely taken up and being used at the moment here in Europe. If there's to be a major increase in production, it's these lands here that will be taken up, possibly also in Africa, which require a hell of a fertiliser addition. So I had a stab at how much extra grain we might produce from here. If the US can produce 100 million tonne per annum of extra corn with a mandated ethanol requirement, there is a lot of land in the US that's gone fallow due to the fact of low pricing, and it's not worthwhile bringing it on. So if we do have high prices, they're possibly going to have another 200 million tonne per annum that can be produced. Russia, I'm told, has 40 million hectares that's not being farmed at the moment. That might produce 90 million tonne per annum of wheat. And Brazil has 190 million hectares. All that adds up to is about 670 million tonne per annum of extra grain, possibly. And I've just thrown this is a bit dated, this is now almost 10 years old, of where the food comes from, which is the dark green, and the major importers. And basically these trends will be reinforced over the next 10 to 20 years. The red will become redder and the green will become darker green. So, when do we run out of food and prices rise due to scarcity? This is a history of percentage increase in world population from about 1950 with a projection out to 2050. You can see here that China's Great Leap Forward. That's when they had a population of 600 million people. And due to a government policy to export grain to pay for arms shipments from the Czech Republic, they basically created an artificial famine and killed 30 million people, 5% of their population. And that's why we've got this spike down here. But it's been world population growth has been declining. We're now about 7 billion people. And based on that estimate, how much more grain we produce, we'll get to the early 30s before we run out of arable land to feed them. Now on to the climate section of my presentation. First of all, I want to disabuse you of the notion that the world is warming due to anthropogenic global warming. And I'll take you through a few slides first before we go into what is going to happen to climate. First of all, if the world was warming, we'd have less Antarctic sea ice extent. This is a graph that's updated daily of the total Antarctic and Arctic sea ice extent in millions of square kilometres. And this is the departure from the 30-year mean. And we're basically on the 30-year mean, so there's no change in that bellwether indication of whether the world's warming or not. That's telling us that the world isn't warming, in case it's any doubt. Let's look at Arctic sea ice extent in particular, because some people are worried about polar bears and the like. This is also updated data, it's available on the web. And this is Arctic sea ice extent in millions of square kilometres by year from 2002. There's 2011, this red line. Still within the pack, there's been no change in Arctic sea ice extent. Let's talk about the atmospheric temperature. The highest quality temperature record on the planet is the satellite record dating from 1979. There's a couple of interesting things here. There's Mount Pinatubo cooling. When Mount Pinatubo in the Philippines blew up in 1991, and we had about a half degree decline in average annual temperature the following year in 1992. We had this El Nino spike in 1998, but we haven't passed that yet. And this is very fresh data. This came in overnight. September 2011 is 0.29 degree above the 30-year average. Basically, no one under the age of 32 has experienced global warming in their lives. The projection out into early next year, this is the Nino 3.4 region, and this is where we are at the moment. And this suggests we have a very large El Nino, La Nina forming. It has formed, it'll get deeper, with a cooling of about 1.5 degrees centigrade into that region into March next year. Now, carbon dioxide as a heating agent. The greenhouse gases keep the temperature of the planet about 30 degrees warmer than it would otherwise be if they weren't in the atmosphere. So instead of having an average temperature of 15 degrees centigrade, it would be minus 15 degrees centigrade. 80% of that effect is from water vapour, 10% from carbon dioxide. Methane and so on make up the balance of the last 10%. So carbon dioxide is worth about 3 degrees centigrade. What I've done in this graphic is there's a website called Modtran maintained by the University of Chicago, which allows you to put in an estimated CO2 content of the atmosphere, which I've done here, and I'll tell you how much the heating effect is, which I've got up here on the left-hand axis, the y-axis. Lo and behold, the first 20 parts per billion is worth half the heating effect to date. The heating effect is logarithmic, not arithmetic. And thus, by the time we get out to the current level of about 392 million parts per annum, every 100 ppm is only worth about 0.1 of a degree centigrade. We're currently putting 2 ppm into the atmosphere each year. That's 100 ppm every 50 years. So we're heating the atmosphere by 0.1 of a degree every 50 years. I'll go back, because there's something that amuses me considerably about this whole debate. In that the Ice Age, during the Ice Ages, which started about 3 million years ago, the carbon dioxide content of the atmosphere got down to 200, well, there's a federal government document that came out about a month ago that told us it got down to 272 million parts per million. 272 parts per million in the Ice Ages. Plant growth shuts down at 150 parts per million. The plants can't operate against the partial pressure differential between their leaves and the atmosphere at below 150 parts per million. So, many times in the last 3 million years, all life above sea level on this planet came within 20 parts per million of disaster, parts per million from disaster. That all life above sea level could have died off due to a lack of CO2. The more we can increase the CO2 content of the atmosphere, the safer all life on this planet will be. Because we will have another ice age. Now, if CO2 didn't cause the warming of the second half of the 20th century, what did? And there's something called the sun. The sun was more active in the second half of the 20th century than had been in the previous 8,000 years. What I've shown you here is solar activity as expressed in sunspot number back to 1700, projection to about 2030. So this is sunspots are magnetic flux tubes on the sun that are counted by astronomers on a daily basis. And what I did in 2006, I published a paper predicting that the Dalton minimum, a period of very weak solar activity here from 1798 to 1822, would be repeated in the current solar cycle 24 and the next solar cycle 25. And thankfully, that is happening. At the same time, NASA's chief astrophysicist, Hardy Hathaway, projecting that solar cycle 24 was going to be a monster, about 190 amplitude. And thankfully, on my predictions being borne out, we are having a very weak solar cycle 24, and it will be followed by a weak solar cycle 25. Now, the significance of that is that's the last time we had a very large cooling event on the planet. The Thames froze over in 1810 here. There's a correlation between the temperature of the atmosphere and solar cycle amplitude, but there is a stronger correlation between solar cycle length and temperature over the following solar cycle. That was first deduced by two Danish researchers, Christensen and Lassen, back in 1981. And in 1996, two researchers at the Amar Observatory in Northern Ireland plotted up to 300 years of Amar temperature data against solar cycle length. That solar cycle length increased on the x-axis there to the right. That's temperature Amar in Northern Ireland on the y-axis. And they produced this plot with very little scatter about the line of best fit. So I looked at that and I said, that's a very useful prediction tool. If we know solar cycle length, we can predict climate. So on top of their graph, I plotted up solar cycle 22 at 9.6 years long, ended in May 1996. Solar cycle 23 ended in December 2008, 12 and a half years long, and based on that 3-year length difference, Amar in Northern Ireland should be 1.4 degrees cooler over the next 10 years than it has been over the last 10 years. Thankfully, that started. Last December, they had a lot of burst water pipes in Northern Ireland due to the fact that they weren't buried deeply enough. And I went on to apply that to a number of other temperature records around the planet. This is Hanover, New Hampshire. And their relationship is 7 degrees centigrade per year of solar cycle length. Solar cycle 23 was 3 years longer than solar cycle 22. So Hanover, New Hampshire will be 2 degrees colder over the next 10 years than the previous 10 years. Significance of that is that's a very good proxy for the latitude of the US-Canadian border. It's going to get very cold in the wheat belt in Canada in the next 20 years. My projection is that Canadian agriculture will be back to trapping beavers in the 17th century. Now, thankfully, an astrophysicist at Oslo University picked up my methodology and he applied it to the temperature record of Norway. This came out in a Norwegian astrophysical magazine last April, and there's Bergen, which is here on the west coast, plotted up. Replicating my methodology, he came up with a prediction that Bergen's going to be about 1.5 degrees colder over the next 10 years than the previous 10 years. And they followed up with a scientific paper using statisticians, all that. So 3 wise Norwegians, led by Jan Erik Solheim, that's me there. The first will length of the previous solar cycle has predictive power for temperature. And what those 3 Norwegian scientists have done, first of all, this is a place in Norway, Donbass, in the southern part of the country, central. They're predicting a 1.5 degree centigrade climb. It's actually already started happening here, the projection. And this is for the whole of the northern hemisphere. They're predicting a 0.9 degree decline, which will take us back to the temperatures in the mid-19th century. We'll have about 20 years of this. And this has passed peer review. It'll be, I expect, to be out in the next month or so. Now, if the new solar cycle length predict temperature, if you can then predict solar cycle length, it's all over. Now, fortunately, there's an electrical engineer in Ohio by the name of Ed Fix, who looked at that solar cycle record, and what we see here is a solar cycle record in green, and he's reversed every second cycle. That reminded him of the ideal spring relationship. So he downloaded the planetary ephemeris data from a NASA website, made up a model, and his model outputs the red line. He's predicting a couple of very weak cycles here, after 2030, and then back to normal by mid-century. So, using Ed Fix's model, from which you're able to predict solar cycle length, my methodology of using solar cycle length to predict temperature, and throwing in the logarithmic heating effect of CO2, we can predict climate out to 2040 with some confidence. And this is what it looks like. The blue is with the CO2 heating effect, and the red's without it. This is down in New Hampshire because what happens in North America is very important. They produce a hell of the world's spare grain. Their growing season is going to be shortened dramatically. They'll have early frost, late springs. They had a very late spring in parts of Canada this year. Now, the world hasn't concentrated on what happens if temperatures fall and the grain belts of the planet contract towards the equator. But the last time the world went through a crisis about climate was in the early 70s, when they thought that an ice age was imminent. This is a fragment from research in that period. This is Canada. The stipple line is the theoretical growing limit for wheat. And the dark black line is what that would shrink to if temperature fell by 1 degree centigrade. So I'm predicting it will fall by 2 degrees centigrade, so it's going to be very dicey to grow wheat in Canada late this decade. Similarly, this is a bit of research from the early 80s. This is the US Corn Belt in the shaded area. If temperature falls by 1 degree centigrade, it'll migrate south by 144 kilometres. The rise will migrate north, and that's that dashed line. That's the Corn Belt as at 2010. But we've seen this in the US before. There was a thing called the medieval warm period, where temperature was much higher than it is at the moment. And that was followed by the Little Ice Age. And this is archaeological dig of that Corn Belt region. That's the limit of the Indian Corn Belt from 1000 AD to 1250 AD. And that's the northern limit of the Indian Corn Belt in the Little Ice Age, 300 years later. Now I'll quickly round up some of the other continents. This is an indication of what might happen in East Africa. There is good correlation between lake level in Lake Victoria in East Africa and sunspot activity. And the blue line is the level of Lake Victoria, the red line is sunspot amplitude. There was a 40-year gap in which relationship broke down. This relationship was known here back in the 20s. It broke out 40 years, then resumed. Now I'm predicting about 30 years of very low sunspot activity, so we should have 30 years of drought coming in East Africa. Similarly in South America, the Parana River is the second largest river in South America. It's got a very large dam on it called the Untitled Dam. And two Argentinian researchers a couple of years ago produced this graph. Blue is sunspot number, and green is the Parana River stream flow. So we're heading for a period of very low sunspot activity, we're heading for a period of very low stream flow. Now what I've described so far is a plain vanilla de Vries cycle cooling event. There are cycles in solar activity. There's an 88-year cycle called the Gleisberg cycle. There's a 210-year cycle called the de Vries cycle. There's a 1470-year cycle called the Bond cycle. A good outcome would be a plain vanilla de Vries cycle event where we lose the Canadian wheat crop and so on. We possibly 2 million tonnes around most of the northern hemisphere rain belt. But that can be overprinted by a major volcano. And what I show you here is Mount Pinatubo in 1991 caused temperature around the planet by 4.5 degrees centigrade. If that's overprinted on a plain vanilla de Vries cycle cooling event, we could have an 1816 type crop failure event in which they had frosts in May and Connecticut in June, and the price of oats rose from 12 cents a bushel up to 92 cents a bushel. And we could see that sort of similar effect in our lifetime. Thank you very much for your attention.
Ladies and gentlemen, I think we might have a few questions.